In this video, we are going to be looking at the unique role of water. So as you already know, water is a polar covalent compound. So looking at our water molecule right here, when we say covalent, we mean that we are sharing electrons. So hydrogen and oxygen are sharing electrons so that they have a completely full octet. And it's polar because the sharing that's going on is unequal. So oxygen has a higher electronegativity than hydrogen, so therefore it's pulling the electrons closer to itself. Or we can say that it has a stronger electronegativity. So that's going to create this negative end on our water molecule. So if we look at this picture on the right, we can see that we have our negative sign and we have our positive sign. So I always like to think that the hydrogens are the happy ones and happy people are always positive. So just remember that the H's are the positive ends and the oxygens are the negative ends. Okay, so also, because we have this polarity, we have an intermolecular force, or an IMF, called hydrogen bonding. So an intermolecular force, remember, inter means between. So if we have water molecules all around each other, as in a glass of water, we have this attraction between the negative oxygen end and the positive hydrogen end of two different water molecules. And that's what we call a hydrogen bond. So hydrogen bonding is when the partially negative end of the water molecule, the O, is attracted to the partially positive ends of other water molecules, the H's. So we create this network of molecular attractions. So water really likes itself, okay? And because of that, we get a lot of interesting properties with water. For example, we get adhesion, cohesion, we get surface tension. This is what allows insects to walk on water, and that's why we have water kind of will bead up or bubble up because it's attracted to itself. Okay, so in this picture, we're just zooming in on that attraction between the two different water molecules. And again, this is called hydrogen bonding. Now, when we are making solutions, solutions always involve water when we're talking about dissolving a solid or a liquid. So a couple of things you need to know about solutions are we have a solvent and we have a solute. So the way I like to remember this is the solute is what you have in the smaller amount, and it's what goes into the solvent. So you can think of this V as kind of like your beaker. So in this example here, we have sodium chloride, also known as table salt. We have that in water, and you already know that that's going to dissolve. So when it dissolves, we create this solution of salt. So it's a salt solution, or we can say an aqueous solution. So most ionic compounds are going to be able to dissolve in water because we know that ionic compounds are made up of a positive and a negative ion. And the unique thing about water is water's polar. So when we're looking at all of these little water molecules in this picture, we see that the negative end there is your oxygen, and the positive ends are your hydrogens. So the positive ends are going to be attracted to the negative part of your ionic compound. And then the positive end is going to be attracted to the negative end of the water molecule. So that's why water is called the universal solvent. It's able to dissolve all ionic compounds because ionic compounds are made up of positive and negative ions. Now, when we have the dissolving going on, we have two different types of water that you'll hear me talking about in class. We have free water and we have associated water. So free water represents the water molecules that are available or they're free to dissolve a solute. Now, the associated water, that's the water molecules that have actively paired with the cation or the anion of the ionic compound. So if we have, let's call this table salt, sodium chloride, we know it's made up of positive sodium ions and negative chlorine ions. If I dump this solid sodium chloride into a beaker of water, my water, before I put my solvent, my solute in, it is all free water. There's nothing in the beaker. But as soon as I put this in, my free water is going to come by my solute and it's going to attract itself to the ion that is opposite of it. So here we can see that the positive ends of the water molecule, which are represented in blue, or the H's, are attracted to the negative chlorine ion. So now this water molecule, all of these water molecules, are now associated water because they are dissolving this component. Same thing here. All of these water molecules, I have the negative oxygen attracted to the positive sodium. So now these water molecules are associated water. So once you run out of free water, you're not going to be able to dissolve any more of your solute. All right, this is another picture just going through what I just explained. So this is dumping salt into water. Okay, so this is all free water. Now in picture B, that's just zooming in on what does the salt look like. Okay, there we have that nice crystal lattice structure. And C is showing how all of the water molecules that were free are now going to associate themselves with these ions. Okay, and that's how we get table salt to dissolve in our water. All right, ladies and gentlemen, that is it for notes 1. So if you have any questions, please make sure that you are writing them down. Thank you.